My name is Marty Smith. I work in the AES-Controls group. I'm sure most of you already know that. We'll be talking about the Epix PV Gateway today. Okay, so I'm going to tell you what a PV Gateway is, what it's good for, what it can be used for, some features of the gateway. I'm using an old version of the code for our PV gateways now. I currently administrate about 40 PV gateways for user beam lines, as well as we also have a gateway that helps us communicate with some of the X-ray BPMs. I'll go over some of those features and the updates to the code since, for the more updated code than what I'm using. We'll talk about remote administration, the monitoring, and the control, and how I go about doing that using MEDM. And I'll tell you how to get started using PV gateways. How can you start one up? What are the files you need? And we'll go over some different gateway configurations that you can use, and we'll have questions at the end. So, what is a PV gateway? It's an Epix extension that was first developed by Jim Kolakowski way back in, I don't even know, I think 1996. Then further development was done by Janet Anderson, Ken Evans, Jeff Hill, since he's the channel access guru. And Ralph Lang, I think, is now the owner of the PV Gateway code. So it's a software application that uses a channel access client to connect Epix PVs and set up monitors on those PVs. It's based on the portable channel access server to provide the PVs to the other channel access clients. They typically are on a different network than your channel access servers or your IOCs, but they don't have to be. There's 5 functional blocks for a PV gateway. So you have the CA server, you have access security in there, you have a virtual connection, data cache, and of course a CA client side. So to go over some of the functional blocks, the CA server is what provides the channel access PVs, the connection to the channel access client. So when you start up your MEDM, it sends out a search request. When the gateway sees it, it will establish that connection to the channel access server in the gateway. The channel access security is configured basically for the virtual connections, which I'll cover that in a little bit here in the next slide. A virtual connection is basically like the go-between between the real PV and the PV that you're asking for. It keeps its own cached value in the gateway, which is this actual virtual connection. That's also what the channel access security is using. The data cache is there's data cache for each PV, and the cache is used by the gateway. The only thing that gets updated in the gateway from the IOC is this cache. So when you do a read request of a PV, the gateway basically gives you that cached value. The channel access client side of the gateway connects the Epix PV to the channel access server or the IOC in most cases. So a little bit of this gives you a little bit of a pictorial diagram of what I was just telling you. So this top part here shows your MEDMs over here, but no connections. There's no connections through the gateway. You got your IOC over here and your PV to the IOC here. Once MEDM connects, sends out a search request and gets that connection from the gateway actually has to go out and do a search on the other network, and the IOC has to tell the gateway, hey, I'm the one who has this. Once this happens, then the channel in the gateway is connected to this virtual connection. And as you can see, all these MEDM channels are all funneled through a virtual connection, which connects to the real PV on the IOC side. And so here's where the channel access clients have all disconnected, okay? But the gateway keeps this connection to the IOC open for a configurable period of time. I use 3 hours. So that way subsequent connections to the same PVs happens a lot faster because it's already cached in the gateway. If you guys got any questions at any time, stop me. So,
Marty, that's a virtual connection? Is that because it's like caching it then? Is that really
right. So that's called a virtual connection because that's the actual cache of the PVs. So every time a PV changes value, the IOC informs the gateway and that cache gets updated.
How much of a delay usually do you see between?
It's no different than having channel access client attached directly to the PV and the IOC. There's the time delay through the gateway is very small. I don't know the number, but I would expect on the order of milliseconds. Okay, so there's only one channel access connection between the gateway and the PV server, such as IOCs, rather than one connection per client. So normally, without a gateway, normally what would happen is you start up all your channel access clients and they all connect to the IOC. Now that might be 20 different connections depending on the number of clients you have, of course. So what the gateway will do is help minimize those TCP connections to the IOCs. VxWorks has an open file limit. I believe it's 256 open files. So once you've exceeded that on VxWorks, or once you've reached that limit, you can't exceed it obviously, but once you've reached that limit, then the IOC will basically just refuse to make the connection. And on MEDM, it shows up as your PV is white. So, like I already said, the read access from clients is answered from the data cache, basically from the virtual connection. So there's no network traffic on the IOC side for read requests. So the IOC sends its monitor only to the gateway. And if there's a channel access client connected, then the gateway will send that data back to the client. And again, the channel access connection is held open by the PV gateway after the last client disconnects for some configurable period of time. Like I said, I use 3 hours, which I believe might be the default, although the documentation, which I will give you the link to that later, says 2 hours. So, okay, so what can we use this PV gateway for? All right, so it's good for getting channel access clients on one network to connect to channel access servers on another network. So, which is typically how we use the PV gateways at APS. We would have a host machine with 2 network interfaces, and one would go to each subnet. And the gateway basically listens on one, so the server will listen on one network, and the gateway client side will talk to the IOC servers on the other network. So you could have different subnets, say on a beamline, for example. A lot of beamlines, they divide up their network into different subnets, and they might have all their IOCs on one subnet and all their channel access clients on another subnet. So this would be a good application for that. You can alias PV names from the real name. You can do it either using the method that I already mentioned about having the two Ethernet connections on the same host, or you could actually alias the names within the same subnet. So you don't have to have a host machine with more than one network connection. As far as the channel access security goes, like I said, that really happens at the virtual connection level. So it's in the PV gateway, so it's a separate additional channel access security than what might be implemented on the IOC. So, for example, for a lot of my IOCs, I in my IOC channel access security, I have the gateway has the ability to control all PVs, has write access to every PV of every field. And then I control the access security within the gateway. It's just simpler to do that way, for me anyway. So I've got two levels of channel access security, which makes troubleshooting that kind of thing a little bit more difficult than if you just have only the one level of channel access security provided by the gateway. The gateway can also give you CA put logging. You can see who changes a PV and where that change was made. I don't know about the newer versions, but the version that I'm running does not show you what the data is. It just tells you this PV was changed by this user at this host, and you don't know what the values are. So just a recap of what I was just talking about. So again, the gateway is both a channel access server and a client. So you can see the gateway would be the server and client here in the middle, in between your channel access clients and the IOC. So it can provide connections between subnets, which channel access doesn't do by default. You can make it do that, but it can be tricky. It provides additional access security if a lot of beamlines don't have any access security on them, for example, on their IOCs. If you wanted it, then you could either put it in the IOC, or you could put it in a PV gateway, or you could do both. And it can provide PV name aliasing for those PV names that are rather obscure and don't really tell you, okay, well, what does this PV mean? So this would be an example of what your channel access connections would look like without a PV gateway. So you have multiple IOCs or other channel access servers running, and multiple channel access clients all connecting to each of these IOCs. So when we put a gateway in between, though, then we get something that looks a little more cleaner like this. The IOC only has one connection to the PV gateway rather than multiple connections to every client. And again, this is great for VxWorks. For soft IOCs, I don't think you have that same problem. I haven't run into a limitation with soft IOCs, but I imagine there is some Linux limitation. Okay, so the PV gateway can run on Linux and Windows, and the Windows build was kind of fixed in a more recent version than what I'm using. There's extensive diagnostic PVs internal to the gateway, but these can only be seen from the server side of the gateway. So if you have a gateway, for example, that's on two different subnets, running on a host with 2 different subnets, you can only see the internal PVs from the server side of the gateway. That means if you don't have a channel access client that can access the server side of the gateway, and you're only on the client side, where normally your channel access clients would, well, normally your channel access clients will be on the server side. But if you don't have access to that, like I don't on the PV gateways for the users, I have to have a reverse gateway that allows me access to come around to the server side and actually see what those internal PVs are, what the values are. So again, you can do CA put logging to a file, and you can monitor and control the gateway remotely through MEDM or whatever your preferred channel access client is. So the APS gateways are running 2.0.4 version, but the newer version is 2.0.6. And you can also build the gateway with an optional heartbeat PV, which I'm not going to cover that part of it, but it may come in handy if you're using a PV name server with the gateway, which is I mean, I could touch on that if you want, but I don't think it's of interest to you guys. Okay, so the newer version has CA put logging has been updated by Frib, so that's been incorporated into the newer version. It now builds against Epic Space 3.15.1, and I assume newer. They fixed the Windows builds in this version. There's support for Perl-compatible regular expressions, and I'll cover a little bit about regular expressions a little later. They fixed the crashes when forwarding empty arrays. I haven't seen that problem. I haven't had a gateway crash and I don't know how long. But if I did, this would be the first thing I would do, is go to the new version. And now the gateway can use variable length arrays for the channel access client side subscriptions. So when I talk about remote administration, we want to monitor the health of the PV gateway. You know, is it running? Does everything look okay? Are people getting channel access connections and that kind of thing? So this is the different states of what the PV gateway process variables can be in. So you got a total number of PVs which the gateway will report to you. Out of those, you're going to have a certain number connected and a certain number unconnected. The connected ones means that the PV is connected to the IOC. Okay, so you can have them connected but not active. All right, they'll be inactive unless there's a channel access client connected to that PV. Then it becomes active. Out of the unconnected ones, it could be either connecting, disconnected, or dead. Okay, so I've never seen, I mean, it connects so fast, I never see any number on the connecting. But a disconnected PV is one that was formerly connected. So it used to be on this side, possibly active, but probably went to inactive, and then after the 3 hours or whatever the time expiration is of the PV gateway for holding that connection open to the IOC, then it becomes disconnected. And a dead PV is basically one that the gateway can't find. So here's a little display here that shows that I use. This is just a part of it. And you can see there's a lot of PVs. These are all internal PVs from the gateway. So I've highlighted some of the more important ones, some of the ones that I look at here. So the client event rate which is actually this column here. We're going to look at the client event and post rates here. This is the rate in hertz at which the ILC client events are happening. So this side is related to the ILC because the client, the gateway client connects to the ILC server. Okay, the client post rates are the rate in hertz at which events are posted from the virtual connection to the channel access server. Okay, so these are the events posted to MEDM and your other channel access clients. These numbers are typically should be pretty close to each other. I mean, you can see one here is a little bit different, but generally they should be pretty close to each other. Then we have an exist test rate. That's the rate in hertz at which the gateway receives search requests. So here we can see that this gateway is currently receiving search requests, but these other ones are not. Okay, and I've seen these numbers go pretty high. That could be an indication that that somebody has forgotten to do a substitution on their MEDM or something like that, and maybe they're looking for a PV with a $ sign in it, or something like that. So, which again, that indicates non-existent PV searches. The loop rate is the rate in hertz at which the gateway executes the main loop. This loop rate should always be greater than 10. Typically, I mean, it's less than 100 typically, but these numbers vary. I mean, I got some 50s and 60s here, and I don't really pay too much attention to that. I pay more attention to the CPU load and these client event and post rates, as well as the server event and post rates, which, so the server post rate is the rate in hertz at which events are posted to the channel access server. That's the channel access server in the gateway. So the server event rate is the rate in hertz at which the channel access server processes these events. So again, these numbers should be pretty close to each other. You should not see a large deviation between these numbers, these two columns, and these two columns here. So that's basically all I use for monitoring. So to control the PV gateway, all right, so there's some internal PVs that we can use to provide a virtual connection report, which is a report of all the channel access clients to all the EPIX PVs. You can get a process variable report, which is a report of all the PVs grouped by the state that they're in. So they could be connected, disconnected, dead, active, inactive. So that report groups them by which state they're currently in. You could get a channel access security report. So it shows you all the PV patterns that are allowed or denied from the PV list file, which I will go over a little bit later. And you can stop the gateway through an internal PV. You can also do it another way, but I prefer just to use MEDM because it's simpler. When you got 40 gateways, you need some kind of tools to be able to control all of them. And I've got also some edit and view menus. So you can see here for the channel access security, I have an edit button, a view button here, and which typically could be the same, and a start button, as well as edit and view for the PV list file. So basically all that is it's a shell script that's attached to that button. It's basically, it's not even a shell script. I do an SSH to the gateway client, whoever's hosting the gateway, and then run an xterm on that machine and execute a VI command within that xterm, and that brings that xterm back up on my host, so that then I can edit and view the different files. So if I want to add somebody to an access security file, I just go to this menu here, and I've got one for each of these gateways. So I just select which one I want, pops up a X terminal for me and a VI editor for the particular file that I'm interested in. So that allows me to edit them remotely right there. Oh, look, I jumped ahead. Okay, so the start command button is that actually executes a shell script. And the way I have to have it is I SSH to whatever host, or as whatever user is running the PV gateway process on the host that the gateway runs on. So you can even do multiple SSHs. I have one shell button that does an SSH as the user gateway to a particular host, and then might do another SSH to the gateway machine that's actually hosting the PV gateway, because maybe you have the machine running the PV gateway has only certain maybe you can only connect from certain machines. So, for example, for the accelerator, I might have to SSH to a Helios client first on the accelerator, and then SSH into the gateway host. So then I just run this xterm with the -e, and I put the path to my startup script. The only thing is for I have actually two startup scripts. They're exactly the same. The only difference is this particular one that's attached to the start button of MEDM has one last line in there so that the X terminal doesn't exit before I can see what happened. Otherwise, basically it's waiting for user input. So, because otherwise, if you don't do that, what's going to happen is your X term is going to pop up and then it's going to disappear, and you're going to be like, well, what happened? You won't know. So, okay, so yeah. And of course, you can reload the access security by hitting the load button, which is on this screen here. So I can reload the access security file on each gateway without having to restart the gateway. So how do we go about getting started? Well, there's some files that you need to have set up ahead of time. You need a PV list file. It's a list of regular expression patterns to match. So when your channel access client makes a channel access request, the gateway looks in this list to see, okay, well, does this PV match any of my patterns that I have? If it does, then it can go ahead and issue a channel access search request on the other side of the gateway. The access security file you need, at a minimum, to allow read access to everything. I never have loaded or run a gateway without the access security file. I don't know what will happen. I suspect, though, that you won't have read or write access to any PV. It's a lot like if you do that, if you load channel access security on an IOC and don't load an access security file, then you'll never make a connection to it. So I think it's similar to that. You need this command file. This file may come with the PV Gateway code. I'm not sure. I've never actually downloaded the code and built it. I run pre-built executables. So But that basically just has a list of commands for the gateway kill signal. There's a special kill command for the gateway that uses the USR1 signal so that it doesn't actually kill the gateway, but rather runs a command from this command file. And of course you need your gateway.starter shell script or whatever you want to call it. I call it gateway.starter because, well, I know that it's used to start it. I'll cover a little bit about how I go about my directory structures for the PV gateways in a little bit, but I use a soft link for my gateway starter file that actually points to the executable code that I keep elsewhere. The reason for that is because what if I want to run different versions? You know, I can keep different versions of the gateway code in one directory and make a soft link to it from where all the other gateway files are at. Okay, so when you start up the PV gateway, it produces these files. It produces a put log, which the file name is specified on the command line. If you want to put log, you have to use access security, and you have to have in your access security file this write, trap write rule for all of your writes. If you're not allowing writes, well, you're not going to really get a put log file anyway. The log file, that file can be specified on the command line as well. It basically has information about the environment variables that the gateway used when it started. It may have information about ILC reboots at particular times because the channel access clients will become disconnected. So there's various different things in the log file. This gateway.reserve is used to reserve a file system descriptor, a file descriptor for the file system, so that I believe it's so that the gateway command file can be run and generate these other files. It basically is like a placeholder for a file descriptor, just to make sure you don't run out. The gateway.killer is a shell script that gets created when you start the gateway, and when you run that on the command line, it kills the gateway. There is also a line in there which I'll show you that is used to run this command file. Then there's a gateway.restart shell script, which will basically restart that gateway process. So when a gateway starts up, if you're running it in server mode, which I always do, it starts two processes. One is the actual gateway process, and the other is a watcher process to make sure that the gateway is still running. So that way, if the gateway crashes for whatever reason, it will automatically restart.
Marty, that log file you got there, that's different from the process log file.
Correct. Yes, that's the gateway log file. So here's some typical command line options that you can use. You use the -log in a file name, the -put log in a file name. I use nice names like gateway.log and gateway.putlog, and just so I know what the different files are. The -prefix and then some string actually sets the prefix for the PV gateway internal process variables. Then you have a -CIP, which is a client IP. It's a list of IP addresses the gateway client uses to find the real PVs. So basically, you would set that to the broadcast IP of where the ILCs live. When you by setting the client IP here, it sets these environment variables. The Epic CA auto list, the Epic CA auto, I missed a word there, adder list gets set to no, and the Epic CA adder list gets set to whatever IP you put here. So that way the gateway knows, okay, I shouldn't broadcast to all of my networks, because, I mean, especially for me, that's important, because I'm running, one of my PV gateway hosts might be running 5 or 6 PV gateways on it. If I have it broadcasting out to all of its Ethernet ports, then everybody is going to see all of those broadcasts. So then you got a -SIP, which is the server IP. That's the IP address where the gateway listens for channel access requests. So this is the IP address of the network that your channel access clients will be on. Then you got a -home and some directory path. This is the directory where the gateway writes its output files and reads all of its input files from. So typically you would put all of these files within the same directory. Then you got a -server option here that starts the gateway in server mode with a daemon to watch the gateway process. Okay, so that if that process dies, it'll restart it. The daemon will restart it automatically, and then you don't have to worry about that. You might have to worry about, oh, somebody's complaining that that my MEDM just went white, and now then my PVs came back, and it's maybe happening periodically. Maybe there's some problem in the gateway. You could look in the gateway log file and possibly get, some clue as to what's going on there. Okay, so those are just some of the command line options. So this would be a typical command line that you would use. I mean, so you got, gateway -log, your gateway.log, then the -put log, and this -signore is, and then you have your IP address after that. That is if you have particular networks or particular host machines that you would like the gateway to ignore channel access requests from. A typical use of that would be in a case such as mine where I have one machine with 5 or 6 Ethernet interfaces running 5 or 6 different gateways and a reverse gateway. Well, if I'm running a reverse gateway, that allows the PVs from what I call the forward gateway, which would be like the Beamlines gateway would be the forward gateway. So their requests would be able to come through, and if I don't do things right in the reverse gateway, then that reverse gateway can actually send that request back around, and I'll end up with a channel access loop because it can send it back to their same network. And then, of course, it'll come through the gateway again, and, so the looping process would continue. So I can tell the reverse gateway, or actually, typically what I do is I tell all of the other gateways to ignore one of the other, I tell one gateway to ignore all the other ones. So, and I have to do that for each of the gateways. So anyway, then you got your PV prefix, and so all of these different options here for your command line, but you can see that gets really long, which is the main reason why I use a script. Okay, so I want to touch on the access security a little bit. This would be basically enough to get you started. So I use this UAG is a user access group. I believe this is all the channel access security stuff is probably in, I believe it's chapter 9 of the Epics manual, but this user access group is basically, I call it gateway admin. You can call it anything you want. You can call it, this is my user group, or whatever you want to call it. It's just a name. But this name has to match what's in the PV list file if you want to allow write access. So then you have, inside these curly braces, you'll have all of your usernames for this user group. Okay, and you can also have a host access group, which would be HAG, and then you give it some name, and then in the curly braces you would put a list of all the host machines that you want to have access through this PV gateway. So you need to have this top box. This allows everyone to read every process variable through the gateway. If you don't have this, you won't be able to see anything. ASG is the access security group, and this is defining a default access security group. I tend to keep my access security groups between the PV gateway and the IOC the same name. That way it's easier to follow things back into the IOC and figure out, okay, well, which PVs are in this group? Because if somebody has a problem connecting, reading, or writing to a particular process variable, it may be related to the access security group. Default basically means that your PV, the ASG field of your process variable is undefined. You haven't given it a name. So it will go into this default group. Rule 1, rule 1 comma read. So this defines your rule. The 1 is the access security level, and obviously the read means read. But in channel access security, there's 2 levels. There's level 0 and level 1. Level 0 means that you basically have access to the val field. Level 1 means that you have access to every field. I think there's, if you look in the access security portion of the EPICS manual, you'll see that I believe it says that there's a couple of other fields besides the val field for access security level 0. But more often than not, you're probably going to want access security level 1 here. Okay, so, and here I've defined a write rule. This is basically saying everybody gets read access to this access security group, but I'm allowing write access to all fields of every PV within this access security group for whoever's in my UAG list in this gateway admin. So whoever I have in this list has both read and write access to that group of PVs. Any questions about that? It's access security is a whole nother animal here. Okay, so this is the minimum PV list file. Yes.
UAG list, is that a bunch of UIDs?
No, it's the actual list of names. You mean the one in the curly braces, right? No, that's whatever maps to that UID. So for me, for example, I got some UID. Maybe my UID is 113 or whatever. But I would put in the curly braces MLS. So you know, because channel access doesn't, I don't know if it doesn't know about the UID, but it will use the actual username, the log name. Okay, so you need to have an evaluation order of your PV list file. This one says that the allow rules override my deny rules. Okay, this file is read by the PV gateway from the bottom up. So it's kind of backwards from what you would normally code file reads from. But so that means that at the bottom you want your more specific PVs. So I would have some gateway prefix and with a star flag. This would be my regular expression pattern that I want to match on this side. Then whether or not you're going to allow or deny that PV that matches that regular expression pattern through the gateway. And then you can have here again the gateway admin. These flag PVs on the gateway are ones that you actually can write to. They allow you to do the report generations, to kill the gateway, stuff like that. So you got to have this gateway admin, and the access security level here has to match what's on this screen here. So we got access security level 1, we got the gateway admin with the write rule here. This trap write is what actually writes to the put log. So you basically channel access will trap that write and tell you, okay, this is who wrote to this PV, and this is where they wrote it from. But again, I haven't seen, the newer version of the gateway may tell you what the value is or was, or both, but I don't know because I'm not running that. So you got to have your most general rules at the top of the file. So I don't show it here. Typically, I would have a .*deny at the top. Why I put allow, I don't know. But I would have a .*deny. So if the PV being requested doesn't match any of your regular expressions, then the gateway will deny access to that and just won't broadcast that out to the other side, forcing all of your IOCs to search through their PV lists. So you can also use this file here to alias the PV name. So you'd have some PV name here, and you'd have the keyword alias, and then you just give it a new PV name. And that's it. You can have an access security group and an access security level if you want. It's not always necessary. But this would be your real PV on the left and your alias PV on the right. I do that a lot for steering PVs for beam lines. So their PVs will be some obscure thing that, and for each beam line it would be different. They'd be called different names. So this allows me to call all their steering PVs have the same pattern on our side of the gateway. So, okay, and again, this is the access security group and level. That's the same as these two here, the gateway admin and the access security level 1. So I mentioned this command file, and this is basically all that's in it. You just put a comment in front of the ones that you don't want it to do. So in this case, I would run report 1, report 3, and reload the access security file. You could put this one up at the top and reload the access security file first, because maybe what you did was you changed the access security file so that somebody can have write access or read access to a particular PV. So you might want to reload the access security first and then run your reports after that, and then you can look in your report, the gateway will generate a file for that. I call mine gateway.report. And you can look in that report file and you can see, you can find that PV and find out, okay, well, did my access security change actually work? So as long as the channel access client is currently connected. So for example, a lot of beam lines will run scripts. They'll run spec or something like that, where the channel access connection is very short-lived. This type of connection to the gateway is very difficult to troubleshoot at best, because the chances of you actually generating a report here to see what's going on while that PV is connected is slim. So, okay, so the uncommented ones, like I said here, will be the actions performed when using the kill minus USR1 from the gateway.killer file. This is what the part of the gateway.killer file would look like. So it commented out, you'd see kill minus USR1, and then there would be the system process ID of the PV gateway. So you basically, what I do is I cat this gateway.killer file, I copy and paste this line right on the command line, and it runs this, what I call my gateway.command file. You can call it whatever you want. And it'll run these reports or reload the access security, depending on which one you want to do. You just uncomment it. So I showed you an example of the startup script or the command line and how it can be very long and cumbersome. Having a shell script like this helps you to not have to remember all those options, for one, okay? And you're starting the gateway the same way every time. So, I do things like I use, so part of my directory structure might be, okay, go to some path where I have a gateway directory. And within my gateway directory, I have all my gateways and, so this dir, for example, is the alias gateway. So, and then the machine name. Because I might have 3 or 4 gateways running on different machines. The only way that I can keep track of that is to just put it in the path. I mean, how else am I going to know, that, that gateway runs on this machine. I got 40 PV gateways running on about 12 different machines. So it's very difficult to keep that straight when you got something like that. If you only have one PV gateway running to do aliasing or whatever, you might not need to have such a disciplined directory structure. So here's the prefix I've just put in here, GW:alias. I put in my server IP, my client IP, which, the client IP is, again, the broadcast IP for the network where the process variable server will be at, or the ILCs. And then the server IP is the side of the gateway that will connect to your clients. Okay, and I have an ignore list here. I've shown that here. Basically, ignore all requests coming from this host. And the put log, minus put log, and gateway.putlog, because I like to keep my file names so I know what's in them. Okay, so then now we're getting to the meat of the matter. Okay, so the first thing I want to do is check and see if the gateway process is already running. I don't want more than one process variable gateway running at a time. If you don't have this script, then this is something you have to do manually. So I create this variable, and just basically I look for this process that's running on the machine. Is it running or not? If it's not running, then my test variable will be less than 2, and I'll just put some echo some string on there saying, okay, I'm starting the gateway, and then I put my big old long gateway command line on here. This minus UID is the user ID that I use. Actually, it's the gateway user account. So you can actually put your UID there if you want. Say if you want to run PV Gateway as a different user and not yourself. Maybe you got a common account that you're using because other people in your group might have to support that gateway or something. Then you can put the UID of that common account here. And of course, then I run it in server mode. And either the file exists or it doesn't. If it does, then it'll run this code. If not, then it just says it doesn't exist, or that we've already got a gateway running on this machine. So it doesn't actually kill the gateway process that's running, but it will tell you that you already have one running. So again, about my directory structures, I basically keep a gateway directory somewhere. So for the APS gateways, I have a certain user account that runs all the gateways. Under that user account, I have a gateway directory. Within that gateway directory, I keep a versions directory, and that's where I keep all of my executable code, all my different versions. It helps me because I may be running different versions on different gateways. So within that gateway directory, I also make a directory for each gateway that I'm going to run. So, for example, if I'm running a PV gateway for Sector 1, I'll probably call that directory PV Gate SO1. And I might have one for Sector 2 that's SO2. That way I can keep all my files separate. I can keep track of easier of which gateway is running under which directory. So within each of my gateway name directories, I make that soft link back to my versions directory to the executable code. This way I can just change my soft link, so if I get a problem with one gateway, one version of the gateway, I can update that and just point it to a new version and just rerun my startup script. So there's different configurations that you can run these gateways in. This is one configuration that this is right out of the gateway user manual. They call it symmetric gateways, where you got 3 different networks. You got IOCs attached to each one. So the gateway for net A has direct access to net B and net C. So this would be the gateway here for net A, the server side is connected to, but the client side is connected to both net B and net C. So if you got an MEDM that's running on net A, it can obviously access all the PVs in the net A IOC, but it can also access PVs in the net B and the net C IOC through this first PV gateway here on the left. So these other PV gateways, so the middle one here is connected to the server side on net B. So that also has connections to net A and net C. So all of these gateways can talk to all the other networks. So this is where you got to be really careful to prevent your CA loops, and this is what a good use of the -signore command line option. So for like the A gateway, we'd want to tell it to ignore the gateway on net B and net C. So no channel access request coming from these 2 gateways can come through here. Okay, because you wouldn't want that. You're going to create a loop between these gateways, and it's just going to create a lot of network traffic, and it won't be pretty. Okay, so this is more of the configuration that I was talking about that we use here at APS. So here, net Z would be the accelerator network, and net A, B, C, D might be, 4 sectors from an LOM. Okay, so I have one gateway connected, the server side, listening to each of those networks, which I'm going to say the beamline networks, net A, B, C, and D, and the client side they all connect to the IOC network or the accelerator. Now, like I said before, the only way that I can monitor the health of these user gateways, which is what I'll call these, is from the server side, which would be the beamline network, which I don't have access to. That's why I have this reverse gateway, where I got the client side sends channel access search requests to all of the networks. So when I ask to see internal PVs from these gateways, that has to come through this reverse gateway and gets broadcast on the other networks, and then it will find the gateway servers for the beamlines. So that way I can remotely monitor the health of those gateways. Actually, I wouldn't be able to monitor them at all without that reverse gateway. And then you have a single network gateway. This is probably the simplest one you could do. So if you want to alias PVs, this is one way of doing it if you don't have multiple networks, and you don't need a machine that has multiple network interfaces then. So you got your ILC here, you got all your channel access clients all on the same network, and there's no reason that a channel access client can't connect directly to the ILC. But if you're aliasing PV names within the gateway, then your channel access client will use that alias name, and then it can only connect through the gateway because the ILC doesn't have that as a real PV name. I don't use the aliasing that much, not like this. I use aliasing in this configuration. So each of these beamlines may have a steering process variable that they use. What it means, I don't really know. And then so I alias it in here so the channel access clients over here can, or actually I alias it in the reverse gateway so the channel access clients on the accelerator network can get those PVs from all these beamlines without us having to remember, okay, well, what's this beamline's PV? No, I can just call them steering A, steering B, steering C, or whatever. And so here's the user manual. You can access this directly from the Epic's website. There's some other references here about the gateway. There's white papers on it, or not white papers, but conference papers are on there as well. Most of this information came from the gateway manual. So I've gathered some from other places, but most everything you need is in that manual. If you got a question about a PV gateway, I guarantee it's in there. Okay, so that's it. Any questions? Any other questions, I should say? No? Okay. That's it. Thank you.